Well, okay, James, thank you for joining us, and you had a very nice presentation. James is a senior runtime engineer at NVIDIA, and discussed OpenMP and OpenACC related issues. You mentioned that there were some examples where OpenMP and OpenACC learn from each other, like presence, structured data constructs. Could you go into more detail of those examples?
So the present, learning from the present behavior actually was a interesting problem, just because with present and OpenACC, when we did OpenACC, we thought, well, the present table is going to be this really expensive thing. You're going to go in here, you have to do all this work, and you're going to come back out, and you'll have spent all this time in there. We forgot the big thing is when you do data transfers to a device, it takes a long time to do a data transfer. So after you start your first data transfer, you can do all the present lookups you want, and they're all hidden behind that data transfer. So in OpenMP time frame, we had already started to learn some of that, and then OpenACC realized that, you know what, if you don't do the present test, you end up with strange user errors that the users need your help to understand, and what that they needed to be told is, you know what, you said don't look for present, but it was there, therefore you didn't use the data you thought you were using. So it started out as a performance thing that actually turned into a correctness issue that we just said, you know what, the correctness problems that come from this behavior just are too big to bother with any possible gain in performance that really isn't real anyway.
Yeah, and then on the other side, there was the default first private where OpenMP got it wrong, and from OpenACC. Yeah.
Unfortunately, I was the one that kind of pushed the default map to from for scalars for OpenMP, because that's really more in tune with what OpenMP does. OpenMP, everything is shared by default, except for with tasks. And until 4.1, when we actually said, you know what, a target construct is a task construct, which is with a different name, then all of a sudden first private behavior becomes normal. And then the question is first private on everything the right idea? Is it just on scalars? Well, scalars, it's really important to be first private, because without first private on scalars, you can't shape your machine, because on NVIDIA you have to describe the machine that you're going to run on, and then you launch your kernel on that machine. And if you can't describe that machine effectively, you have a slow kernel. Even if the kernel could run extremely fast on the architecture, it runs slow because it isn't given enough resources. So.
And then there's the example of structured data constructs where OpenMP and OpenACC both got it wrong in the first time.
Yes, that's when we did it. We had when Cray did what we did, and Intel did what they did. We had different target audiences. Cray is HPC. That's all Cray does. NVIDIA is a little more wide out. So now that I'm at NVIDIA, I have to link a little broader. But at Cray, when I was there, I was thinking HPC. And HPC, C++ isn't that important. C++ codes in general don't optimize well on all compilers. Some compilers do a great job with it, others don't. So we weren't thinking about those users. Unfortunately, those users do actually want to run their code on devices. And they could run them very effectively if they were using the Intel offload model. But they couldn't with OpenMP. So we had to go back and look at what did we get wrong, which was very obvious, and fix it. And both OpenMP and OpenACC very rapidly identified the problem and fixed it in essentially the same manner.
Okay, well, thank you very much for your contribution.
Sure.